Class 4 is, how do you define a circle? It's what?
Curves.
No straight edges, I heard.
Curves.
Has curves.
Wrong packet.
Anybody else? 360 degrees around. Anybody else? Well, the radius is going to be our next definition.
Closed curved line.
What?
A closed curved line.
A closed curved line. It's not bad. Okay. Consistent pi. Oh, consists of pi. Well, our circumference consists of pi.
The shape of pizza.
The shape of pizza. Okay. What if you get a square pizza?
Who has square pizza? Way to ruin
Freschetta. You've never had freschetta pizza? It's pretty good. No? Oh, yeah.
A 2D version of a sphere.
2D version of a sphere. All right, so we're getting some good things in here. All right, so it is essentially the set of all points equidistant. We've used this word quite a lot this year. Equidistant from a given point. Okay? So I'm going to draw a circle above. Okay? I'm going to mark this point A. This is going to be our given point. And then I'm going to draw a circle around it. So our given point, what would you call that?
Oh, that,
What's it called? That's the center of the circle. So when we define a circle, we're saying that all the points on the circle, okay, and if I were to, put in random points, they're all the same distance away from A. What is that distance called?
Radius.
The radius. Very good. Okay, so in a circle, the radius is the same throughout. Think about like spokes on a bicycle, okay? So that's what that is referring to. And when they say equidistance, the radius is the same from the center to any point on the circle, okay? Question. All right, radius. How would you define the radius? Half the diameter. Is that what you were going to say, Ashley? Yep, that's very good. Okay, so it is the distance from center to the circle. Okay, and just we designate it with a lowercase r. All right, what about a chord? Have you heard that word before?
Yes.
All right, what's a chord?
2 points in the circle.
Okay.
Distance between 2 points in the circle.
Very good. So if you take any 2 points on the circle and draw a line, that's a chord. Okay? More specifically, it is a line segment, and I'm specifically using this phrase, with endpoints on the circle. Okay, so an example is going to be BC. Okay, and I'm going to go BC with a dash over the top. If you remember from chapter 1, a line segment doesn't have arrows. It means it has endpoints. Okay. All right, what about a diameter? What's the diameter, Charlie?
It's like 2 radiuses put together.
Okay, so it's 2 radiuses put together, so it's 2r. Radii for plural.
It's like a distance between 2 points on a circle, which is like through center.
All right, so it is the distance across the circle, but as she said, it must pass through the center. So a simple way of saying this, it is a chord, because a chord is a line with endpoints on the circle that passes through the center. All right, the diameter is going to be the longest chord possible. Okay, so an example here is this line that I just drew, and I'll label it, we'll go D and E, passes through the point A. So it still looks like a chord, it still looks like BC, but it specifically passes through the center. Okay? All right, a secant. 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 It's like a segment. It's not going to be a segment. In fact, we're going to define it as a line that passes through a circle. Okay? So the difference here is I'm purposely drawing it over BC, and the reason is the secant BC has arrows on it to designate it as a line, whereas BC, the other one, is a line segment. Okay? That I will definitely quiz you on to make sure you understand the difference between a chord and a secant. I will purposely use the same two letters to make sure that you understand the difference. Okay? So remember, chord is a segment, secant is a line. Tangent.
I don't know how to say that. It's like just a line in a circle, which is like just like I don't know how to say it.
Yuri, do you know? A line that what? All right, it is going to be perpendicular to the radius. We're going to learn that today, okay? But it is a line that touches the circle as opposed to passing through the circle. Okay, as in it only hits the circle once, like a bat hitting a baseball. Okay, it only hits it once. So I'll draw a picture of that. I'll use a purple line. Okay, so a tangent, oh, it'd be in blue, sorry. All right, so a tangent line is like the one down at the bottom. Notice that it only touches the circle. It does not pass through it. All right, so to check for understanding, we've got four examples down here. What would you label AC as?
AC.
Radius. What would you label AB as?
Diameter.
Yep, doing good. DE?
Tangent.
Try tangent. Very good. Notice that it only touches at B. And AE? Secant. Very good. What's your question? A chord and a secant?
Yeah.
All right, so I'll give you a good example right here. Okay? So AG is a chord, AG is a secant. One is a segment, so it goes from A to G only. The secant keeps going through the circle and beyond. Okay? All right, on example 2, you're supposed to find the length of the radius and find the length of the diameter using the graph given. Okay, and then what we're going to do is we're going to talk about the relationship between the radius and the diameter, which some of you have already mentioned. All right, Philip, what'd you get for the radius of A? 3. Ashley, what'd you get for the diameter of A? All right, what do you see about the relationship between those two?
Double.
All right, you double the radius, you get the diameter. You take the diameter, you cut in half, you get the radius. Okay? All right, so symbols, okay, when they use this idea of that A there, they're saying circle with center at A. That's what they're trying to say. So that now we're talking about circle with the center of B. Okay? Alina, what'd you get for the radius of B? 2. Fatima, diameter. All right, and notice 2 doubled still is 4. And 4 cut in half is 2. Good. All right, going on to the back side. Okay, concept here is going to talk about what happens when circles intersect. Okay, so for example, to start it, I can have 2 circles intersect more than once. How many times are these 2 circles intersecting? Twice. Okay. Is it possible to get 2 circles to intersect more than 2 times?
No.
So next, options are you can have them intersect once, and there's two different looks to this. Okay, you can basically have them just touching once, okay? Or you can have one circle inside of the other circle just touching once. Okay? Yeah, they're hard to draw. Okay? Then you can have them not intersect at all, so you could basically just have two circles side by side. Or you can have one circle inside of another circle, think like a dartboard or a target, okay? If they have the same center, they are called concentric circles. You'll see that phrase later, concentric circles. Okay, that means that they have the same center. Now, the reason why we're talking about this is because it's going to lead us into common tangents. Tangents are lines that touch the circle. A common tangent is it just touches two circles. Okay, so for example, with our picture up at the top, I can draw a common tangent that touches both circles. Okay? Now, when it is on the outside of the two circles and as in it doesn't pass in between, this is known as an external tangent. Okay? If the line passes in between the two circles, like I'm drawing here, okay, then it's known as an internal tangent. So if the line is in between the circles, it's an internal tangent. Think IN, IN, okay? So when you get down to the bottom, okay, you can actually have both, and you can have both on some of these other ones, okay? I can draw this line that touches and touches. Internal or external? External. Then I can have this line that comes in and touches this circle and then touches this other circle. Internal or external?
In.
So this is an internal and this is an external. Does that make sense? All right. So with the concentric circles over here on the right, can I draw a common tangent?
No.
No, I can't draw an internal or an external. Okay? All right, to double check that you understand the meaning, see if you can draw your own on examples 3, 4, and 5. Okay, so if you draw an internal, okay, label it with like an I or an INT, and if you draw an external, label it with like EXT for external. Make sure you understand the difference. Okay, so I saw people doing an internal touch. I saw people doing an external, okay. This one, internal, right in between, okay. External, again, touch, whoops, got a little carried away, those look more like secants. Over here, I drew an external. Now the question is, can I draw an internal? As in, some people were drawing this line. Is that touching the circle or passing through the circle? So that makes it what line? Secant. Okay, not a diameter because it doesn't pass through the center. Okay? All right, on the piece down at the bottom here, okay, the picture kind of cut the theorem. So a line tangent to a circle, if and only if it is perpendicular to a radius of the circle. So if it's tangent, it's perpendicular to the radius, and that's what they're showing here in the picture. So the blue line is perpendicular to QP, the radius. Okay? If it's not perpendicular, then it's not a tangent. Okay? So on the next page, first thing we're going to do is determine whether or not ST is a tangent. So that means the question is this a right angle?
Yeah.
How can we figure that out?
Well,
Use math.
Pythagorean theorem.
Pythagorean theorem is absolutely correct. How can we use the Pythagorean theorem?
I thought she was about to say absolutely incorrect. So it's probably really-
Well, you have the A, B, and C.
Okay? So basically,
And the right triangle.
if 12 squared plus 35 squared does equal 37 squared, as in if A squared plus B squared does equal C squared, What type of triangle is it? A right triangle. So this is what the question is asking. Is it a right triangle? If you get a yes, then it's a tangent line.
Oh my gosh.
If you get a no, then it's not a tangent line. And for a quick review, we talked about if a squared plus b squared is greater than c squared. What type of triangle would you have? Acute. If a squared plus b squared is less than c squared, then it is obtuse. All right? So you are basically determining whether or not this is the right triangle. Yay, nay?
Yes.
It works? 12 squared plus 35 squared does equal 37 squared? All right, so since you're saying that this does work, then that means that your ST is tangent. Yes. Okay? All right. In example number 7, the reason why we focused on what we did yesterday with our factoring review. The first thing you have to understand is it's telling us B is at a point of tangency. Point of tangency is the point at where it's tangent. That means that this is a right angle. Okay, so we have a right triangle. We can use the Pythagorean theorem, like Philip said, to solve for R. So yesterday, I put this up on the board. How would you write an expression for the hypotenuse? R plus 50 or 50 plus R? Does it matter the order? No. Okay, so we'll just go 50 plus R. All right, so we're going to use the Pythagorean theorem, and we're going to say R squared for A squared plus 80 squared for B squared equals 50 plus R squared. We saw this yesterday with our parentheses squared. What does that mean that we have to do?
Multiply.
Multiply. How are we going to multiply? We're going to write it twice. We're going to do 50 plus R times 50 plus R. And then what concept do we have to use? What four-letter word? It's an acronym. FOIL. First, outer, inner, last. Okay? So, see if you can FOIL. See if you can do the R squared plus 80 squared. And then I'll catch up to you. See what you get. All right, did we get R squared plus 6,400 equal to 2,500 plus 100R plus R squared? 50R and 50R make 100R when you do the foiling. Okay? Now, the nice thing is, when I go to subtract the R squared and subtract the R squared, what happens? Cancels out of both, which is nice, which means I don't have to do any factoring in order to solve for R. Okay? And now I can just simply solve for R by doing what?
Subtracting 2,500.
What's 6,400 minus 2,500? 3,900 is equal to 100R.
Divide by 100.
If you divide by 100, what do you get?
100.
Yeah. 39.
R is equal to 39. Okay? 39, yes. All right? Good? Make sense? All right, so you try one all by yourself then. It even says on there, you try. All right, did you get x squared plus 56 squared equal to x plus 32 squared? X squared plus 3,136 equal to x squared plus 64x plus 1,024. X squareds cancel. Subtract the 1,024. You get 2,112 equal to 64x. Divide by 64 and you get 33. Very good. Any problems with that? The big thing is you have to make sure you understand that the x and the 32 represent the hypotenuse. That's the one that goes in parentheses, not the other ones.
Yes, ma'am.
Okay?
Is that 4 or y?
64x?
1024.
1024. Yes. Okay? All right, last piece of information. Okay, if you flip over, the theorem says that when tangents from a common external point S is the common external point because it is outside of the circle. SR is tangent, ST is tangent. They are both tangent to the same circle. So they are common external or common tangents from an external point. Well, if that exists, that means that they are equal. Tick, tick. Okay? We could do a proof where you have to show that the triangles end up being congruent to each other by SSS. Okay? Or you could just take my word for it that they end up being equal. So when you do example number 8 and you want to solve for x, ideas. Just set them equal to each other. 3x plus 4 is equal to 28. Subtract, divide, and you got your answer.
All right.
Okay?